Hi, Advanced Algebra 2. It's Mrs. Langford, and I just wanted to give you some extra notes and practice on how to find a common denominator, or we can call it a least common denominator, when we are adding or subtracting rational expressions. So the basic concept is that you're finding a common denominator like you would with a simple fraction. So when you start, the first thing you look for with rationals is if you can factor any of the numerators or denominators. And you're going to do that separately. So you're going to factor all your numerators and denominators of each rational expression. Then you're going to build your least common denominator. So think of it as building. And the way you're going to build it is by using one of each of the factors from each of the denominators of the expressions that you are adding or subtracting. Remember, whenever you have a number added or subtracted to a variable, that makes it different from just the variable itself. So for example, x on itself is different from x plus 1. So here's just a simple little analogy that I use to help you think of how to build a common denominator. Think of a potluck dinner. When you go to a potluck dinner, everybody has brought dishes and they're on the table. And usually there are repeats of dishes. So let's say you've got, 3 different choices of lasagna, 3 different choices of salads, and 5 different choices of desserts. Now, I don't know about you, but building my plate is a lot like building my denominator. So I go along the table and I choose one of everything. So I don't get 2 lasagnas. Well, sometimes maybe I do, but I should just get 1 lasagna, the one that looks the best. I don't need to repeat. I know it's silly, but with rational expressions, it's the same thing. You don't have to repeat variables or expressions. When we get into examples, this will make more sense. Then finally, you're going to use that least common denominator, that's what LCD stands for in these notes, and adjust each of your numerators, just like you would with a simple fraction. And you're going to do that by multiplying by anything that was missing from that common denominator. All right, so let's try some examples, and I have those steps off to the side. So we're looking at the first one I have a star by, and if we can factor or simplify those rationals, and we cannot. So now we're going to build our common denominator, or our least common denominator. So first I look at my denominator on the left, pardon me, and I need the factor of 2 and an x squared. Now the one on the right, I need a 3 and an x. But I already have an x, it's contained within the x squared. So I don't need to put another x down. So now I'm going to multiply that 2 and 3 together to get 6. So 6x squared is my least common denominator that contains all the factors from each of my original denominators. 6 is a factor of 2, and it has a factor of 3. X squared has a factor of x. So now I'm going to adjust. I'm going to multiply numerator and denominator of each rational by what was missing in the common denominator. So on the left, I need to multiply by 3. And on the right, I need to multiply by 2x. So that in both of our denominators, we get 6x squared. Now I'm going to subtract my adjusted numerators and put that all over one common denominator. And I just put my numerator in standard form, so negative 8x plus 21. The last thing is see if you can simplify that rational, which we did in concept 39, I think. We cannot factor or divide anything out, so that is simplified, and that's our final rational expression. Now let's look at the second one. We're going to see if we need to factor either our denominators, and we do not. So now we're going to build our common denominator. So we need to have factors from each denominator. So I need x minus 1 and an x plus 2. Then I'm going to multiply each rational by what I was missing. So I was missing an x plus 2 on the left and an x minus 1 on the right. Now with my numerator, I need to go ahead and distribute. So 2x plus 4, and then distribute, I put that over my common denominator. Denominators we leave factored. Now on the right, I'm going to distribute my 4 and put that over my common denominator. Now I can combine my numerators. I can add those together. So 2x plus 4 plus 4x minus 4 all over, and I just write my one common denominator. And now I can combine like terms in my numerator, and then just check and see if I need to simplify anything. But there's nothing that will factor or divide out for me. So this is the rational that I get when I add those two original rationals. Okay, let's try a couple more examples. I'm leaving the steps up over on the right. I'm always going to look and see if I can factor anything first. And on the left, and just remember, pause this video anytime you need to write down problems or get completed steps. So let's build our common denominator. We need the term factor on the left, x plus 4, and the one on the right. It's just like the last example that we did. We're going to multiply by what was missing from each of these denominators, so x minus 3 on the left, x plus 4 on the right. Now with the numerator, and I'm going to start collapsing steps so you can see how these problems can move a little faster for you. We're going to distribute the 6, so we get 6x minus 18. I'm going to distribute my 5x, so I get 5x squared plus 20x. Now I'm going to combine the numerator. So notice I have to subtract everything in the second expression. So negative 5x squared minus 20x, all over my one common denominator of x minus 3, x plus 4. So notice once we get a common denominator, it just holds in factored form. Numerator we have to combine and simplify. I get negative 5x squared minus 14x minus 18. I'm going to check and see, can my numerator factor to try to simplify? And it does not. So that is our final answer. All right, look at the next one. Write that one down. And notice our denominator on the left can be factored. So we're going to look for two numbers that multiply to give us negative 18 and combine to give us 7, which is 9 and negative 2. So it will factor as x plus 9 times x minus 2. And then I'll just rewrite my second expression. Now let's build our common denominator. So we need x plus 9 and x minus 2 from the expression on the left. And on the right, that denominator is x plus 9. We already have an x plus 9, so we don't need to add another one. And so we're going to only need to multiply the expression on the right by x minus 2. Now I'm going to combine my numerator and distribute that 6. And I'm just going to put that all over one denominator. Now let's just simplify the numerator, and hopefully you're really getting the pattern of how to combine and simplify these. I do notice that I can factor a 2 out from my numerator, and I do that just to see if anything would divide out for me between my numerator and denominator, and it will not. So I check and see, is it simplified? And yes, it is. Okay, I hope you're getting the hang of finding these common denominators and adding or subtracting. We're going to work 2 more examples to seal the deal. So write down the next example. Notice that we can factor our denominator on the left. So we're looking for numbers that are multiplied to give us negative 24, combined to give us negative 5. So I came up with negative 8 and 3. So I'm going to rewrite my denominator on the left with those factors. All right, now hopefully you're getting good at building that common denominator. So I need both of the factors from the rational on the left, and x minus 8 from the rational on the right is already a part of my common denominator, so I don't need to add anything else. But I do need to multiply that expression on the right by what was missing, x plus 3. So now you know what to do. Let's combine those numerators. We're going to distribute that 3x all over our common denominator, leaving it factored. We'll combine like terms. Check and see if anything will simplify. There's nothing I can factor out of 3x plus 16. So that is in simplified form. All right, now the one on the right, x squared minus 3, it looks like that would factor, but it will not. It is not a difference of squares. So it's going to stay, but my denominator on the left will factor. So two numbers that multiply to give us negative 16 and combine to give us negative 6 is negative 8 and 2. And hopefully my negative's there. There it is. So I rewrite that in factored form. And I just, there we go. And then build a common denominator, which I bet you can already tell what it's going to be. X minus 8 times x plus 2. You're going to multiply that expression on the right by what was missing, and then we're going to combine our numerators. Now, I'm going to do that in 2 steps because on the right, I've got this multiplying I need to do. So I need to multiply x plus 5 times x minus 8. So I'm foiling, and I did that in my head. So x squared minus 3x altogether minus 40. Now I'm going to combine my numerators. Notice in the second expression I have to subtract each of those terms. So I get a negative x squared plus 3x plus 40. Sometimes it takes a while just to get everything combined and simplified. So now I simplify my numerator. I get 3x plus 37 over x minus 8, x plus 2. I can't factor out anything from 3x plus 37. I'm checking to see if it's simplified, and it is. All right, so there's some extra practice on finding common denominators, least common denominators between rational expressions, and then adding and subtracting them and simplifying. I hope that was helpful.